And welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of parent functions. This is standard A.7C in the great state of Texas, and we are using item number 13 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a graph f of x equals x squared. So this is going to be your basic, we'll call it our parent function. It's our starting function, and we're going to transform it somehow. And here is your most basic quadratic equation you can think of right there. So that f of x equals x squared, so there's your f. And we've got the origin right there is our vertex, and it sits right there on the y-axis so that it's symmetrical with it. There you go. It's the most vanilla quadratic function we can think of. F of x equals x squared. It was transformed, though, to create the graph of n of x equals x squared minus 1. So this is what we did. We just did a minus 1. So what does that do? So look at our options. Vertical shift up, vertical shift down, horizontal shift left, horizontal shift right. So it's going to move somewhere, up, down, left, or right. We just got to figure out which one. Okay, so let's take a look at these options here. So let's take a look at these vertical shifts, and then we'll take a look at the horizontal shifts. Okay, so the vertical shifts, if we want to think of our n of x here, equals x squared, and then we'll say plus c. All right, so when we have an addend after our x squared, this is what deals with our vertical shifts. It either goes up or down. How do we know which one is which? Well, c. If this c happens to be greater than 0, that means it's a positive number. It's actually going to be a vertical shift up. If c happens to be a negative number, that means it's less than 0, then it's going to be a vertical drop or a vertical shift down. So right now I'm looking at this negative 1, and that looks like that c equals negative 1, which means it would fit right here. So I'm thinking it's going to be a vertical shift down. But what about these other ones? How do we get these horizontal shifts to the left? How do we get these horizontal shifts to the right? Well, it's very similar, but we would look at it like this. This n of x equals, and then what you do is you actually have the inside the parentheses, x plus, we'll call it d. Then you square it. So the addend actually comes in with the x before it gets squared rather than sitting outside the x. Now this is where it gets a little bit weird, because it does deal with our left and right there, that d. But when d is greater than 0, it's going to be a horizontal shift. Now when numbers get positive, left to right, typically the x-axis, we go to the right for positive, but it's actually counterintuitive. It's actually the opposite here. A positive d means you shift it to the left. So it's a little bit strange. When it's less than 0, that means it's a negative d, negative 5, negative 1. That's when you actually shift it to the right. So it's opposite of what you think it should be. So I'm thinking this x squared minus 1 is going to shift it down. I think it's going to be something kind of that looks like this. Just sits right underneath there, but let's open up our graphing calculator to double check. So we're going to hit our y equals. We're just going to plot. First, let's get our parent function in there, x squared. So that's pretty basic, pretty vanilla. Now we're going to look at this x squared minus 1. So x squared minus 1, it's going to be red, and what we're going to see is it's going to shift it down just a little bit. And that's exactly what we predicted. And so we are going to say our answer here is C, is vertical shift down.